So this is the 12th session on rigid body kinematics. And this also I'll take up problems on SRC project of velocity. Okay. So if you don't know the theory of this problem of theory underlying the problems of this type, you must first note down the 7th and 8th videos on rigid body kinematics, and then you must come to this one. Okay. But if you know the theory, then you can directly come to this. Fine. So I'll write down the problem. Okay. Write down the question here. Fine. So before going ahead, I'll mention one thing. You know the section formula in coordinate geometry. P1, P2 are 2 points whose coordinates are x1, y1 and x2, y2. P is a point lying on the line segment P1, P2 and dividing internally in the ratio lambda is to mu. And coordinates of point P are x coordinate is given by lambda x2 plus mu x1 by lambda plus mu. Y coordinate of P is lambda y2 plus mu y1 by lambda plus mu. That you know. I hope from coordinate geometry you know it. There is one more technique which is very useful in solving such rigid body kinematical problems. So I'll write down that result here first. See, the problem is this. Let's suppose we are given a coordinate system. Okay. We are given a three-dimensional coordinate system. This is the origin of the coordinate system. P1 and P2 are 2 points. Position vector of P1 is R1. Position vector of P2 is R2. This is the line segment joining P1, P2. P is a point lying on this line segment and dividing this line internally in the ratio lambda is to mu. That means distance PP1 by PP2 is equal to lambda by mu. Okay. PP1 by PP2 is equal to lambda by mu. So this section formula here, this is alright. So coordinates of, let R be the position vector of point P. So you know from section formula in coordinate geometry that R will be written as lambda R2 plus mu R1 by lambda plus mu. This I suppose you know coordinate geometry formula. Okay. Now suppose distance between P1 and P2 is constant. So let the distance between P1 and P2 be constant. Okay. Now suppose P1 moves at a velocity v1 and P2 moves at a velocity v2. I show it here like this. Randomly I show them. Okay. Velocities of P1 and P2 are v1, v2, but the distance between P1 and P2 is constant. Fine. That is the line P1, P2 is a rigid line. Line P1, P2 is a rigid line. Okay. Fine. So let P1, P2 be constant. That is, distance is constant. Now suppose this coordinate system is attached in frame F. F is the frame of observation. So we know that from kinematics that V1 is just equal to dr1 by dt in frame F and V2 is just dr2 by dt in frame F. This you know very well. Now let velocity of point P be V. Velocity of point P is V, that is equal to dr by dt derivated r with respect to time in frame F. Now for this vector r, we use this formula substitute here. So this becomes d by dt of lambda r2 plus mu r1 by lambda plus mu. We derivate this in frame F. Alright. We derivate this in what? Frame F. In frame F we derivate this. Fine. Now suppose for a given choice of point P, since the distance P1 P2 is constant, therefore for a given choice of point P, lambda and mu are constants. So since distance P1 P2 is constant and for a given point P, for a given point P on line P1 P2, lambda and mu are both constants. Fine. Lambda and mu are both what? Constants. Alright. Now add up this one. Alright. Now, lambda and mu, I derivate this taking lambda and mu to be constants. Only R1, R2 time derivative has to be taken. So velocity of point P V becomes lambda times dr2 by dt in frame F plus mu times dr1 by dt in frame F upon lambda plus mu. Now this becomes V2F, this becomes V1F. So this is simply write as V2. F I don't write here. F is implied. Plus mu times V1 upon lambda plus mu. So this is a section formula for velocity of point P, which divides the rigid line P1 P2 internally and the ratio lambda is to mu. Alright. And if you derivate it still further, you get accelerations also. But that I am not writing here. That I'll see in the coming videos that we'll discuss later. So this section formula of velocity has to be remembered. Okay. This important formula. It has to be kept in mind. Fine. So it's an important formula. To be kept in mind. Okay. To be kept in mind. So it has to be remembered as a standard formula. Okay. To be remembered. To be remembered. Okay. So V becomes lambda V2 plus mu V1 by lambda plus mu. Alright. Fine. Now what I'll do, I'll take up one or two numerical problems based on this concept of section formula. Alright. So this I'm rubbing it. Okay. So one thing should be known, this is a vector summation. It's not just scalar summation. V2 and V1 are vectors. So to find V, you have to carry out the vector summation of this. Fine. I'll grab it. Okay. So, if we are told to find the magnitude of V, that is just the magnitude of mod of lambda V2 plus mu V1 by lambda plus mu. Okay. The lambda and mu are positive, so this comes outside the modulus. Now this we can write as parallelogram law. We can write it as root under lambda V2 whole square plus mu V1 whole square plus 2 lambda mu V1 V2 by lambda plus mu into cos theta, where theta is the angle between V1 and V2. Theta is the angle between V1 and V2. Fine. Theta is the angle between V1 and V2. So using this formula, section formula, we get V. So this formula also has to be remembered. Okay. Fine. Now I love this one. I take up a question based on this concept. Section formula concept. Okay. So I'll take up a numerical based on this section formula for velocity. Okay. The problem is this. So given a rigid rod, of length L, rod P1 P2 of length L as shown below. Given a rigid rod P1 P2 of length L as shown below. This is the length L. Okay, fine. Now velocity of P2 is given to be 20 meter per second at an angle of 60 degree with respect to ground frame. Okay. And velocity of P1 is given to be I'll just write down the formula. Velocity of P1 is given to be say 10 root 2 meter per second. Okay. Now question is this. Okay. Question is, find the speed of point P. This line P and P2 is rigid, okay? Of point P lying on this line and which subdivides this rod internally in the ratio 1:2. Okay. So what I do, I draw this diagram here. This is P1, this is P2. Velocities of P2, speed of P1 is given, velocity of P2 is given. Angle velocity direction of P1 is not specified. Alright. Now P divides this line internally in the ratio 1:2. That is P is somewhere here. So from this formula, PP1 by PP2 is equal to 1:2. PP1 by PP2 is equal to 1:2. Okay. So this means lambda is just 1 and mu is equal to 2. Now we have to know the velocity of P. Alright. Fine. So using that section formula which we discussed just now, this theory is going to be applicable here. So this we write Vp is equal to lambda times V2. V2 is the velocity of P2, this one, plus mu times V1. Magnitude of V1 is 10 root 2 by lambda plus mu. Alright. Lambda is 1, mu is 2. So I substitute here. So this becomes V2 plus 2 V1 by 3. Okay. So Vp becomes how much? V2 plus 2 V1 by 3. Now we have to find the magnitude of Vp. Okay, fine. So this I'll rub this, okay. This I'm not rubbing because it will be used. So we have to find the speed of P, that is magnitude of Vp. Speed is the magnitude of velocity, this is well known. So Vp becomes root under, use the parallelogram law, 2V1 whole square plus V2 whole square 2 times 2V1 into V2 into cos of theta by lambda plus mu becomes 3. Now what is to know Vp? We must know V1, V2 and theta. Now V1 is known, speed of P1, V1 is known. V1 is given to be 10 root 2 meter per second V1, alright. And what about V2? V2 is the speed of point P2, that is 20 meter per second. This is also known. Now you must know theta. Now theta is the angle between V2 and 2V1. That is the theta is the angle between V2 and V1. That is theta. For that we must know the angle between V2 and V1. But this is V2. This is V1. Now how to find theta? Theta is the angle between V1 and V2. Fine. The question is how to find the value of theta. So for this we must, if we know the angle which V1 makes with this line, then we can from geometry we can determine theta. Let us denote this angle by phi. So what is theta is going to, first we determine phi now. Now how to find phi? Phi we find by similar method. Rod P1 P2 is of constant length. So component of velocities of P1 and P2 along the rod, they are equal in magnitude and direction both. So component of 20 along this line is 20 cos 60 degree. 20 into half. Component of this along the rod is 10 root 2 cos phi. Now in this 20 by 2 10, this 10 they cancel out. So cos phi becomes 1 by root 2. So phi becomes equal to 45 degree. Alright. Phi becomes how much? 45 degree. Now what is theta going to be? Theta is the angle between V1 and V2. This is 45 degree, this is 60 degree. So theta by geometry will be 60 degree minus 45 degree, that is 15 degree theta is going to be. So here theta has to be replaced by 15 degree. Alright. And then we'll obtain the required answer. So I write this one. Okay, fine. So theta becomes 15 degree. So this is a substitute here. So Vp becomes root under 2V1. 2V1 is 20 root 2. 20 root 2 square is how much? 800. Plus V2 square. V2 is 20. So V2 square becomes 400. 2 times 2V1 becomes 20 root 2. And V2 becomes 20. And cos 15 degree by 3. So this becomes how much? This becomes 1200 plus 400, 800 root 2 cos 15 degree upon 3 meter per second. Now 100 comes outside, that is common. 400 is common. 400 root becomes 20. 20 by 3 root under 3 plus 2 root 2 cos 15 degree meter per second is therefore the required answer. Okay, so cos 15 degree you leave it, that you can see from the table, or you can calculate this also. If you write 15 degree as 60 minus 45 and then cos A minus B formula you break it, that you can do, but you leave it like this, there is no harm. All that, as long as the expression is correct, it's all right. Fine. Now you have the first column. Fine. So I'll take up one more problem based on this concept. Okay. So question 2 is this. P1, P2 is a rigid rod. P1, P2 is a rigid rod which rotates in a vertical plane as shown. All right. P is a material point of the rod. Material point of the rod which divides it internally in the ratio 2:3. In each of the two given cases, find the speed of point P with respect to ground. with respect to ground. All right, fine. This I have it, okay. This section formula concept is very powerful, okay. In many questions, if you use this concept, problem can be solved very easily. Especially when you're given this type of data, then section formula is very useful. All right. So two problems will be given. Okay. Problem A is this. This is the rod P1, P2. Okay. Length L it is given. Constant. Let's some constant. P1 has a moving velocity of 10 meter per second rightward. P2 has a velocity of 20 meter per second leftward. Both the velocities are with respect to ground. P divides it internally in the ratio 3:5. 2:3, sorry, P. As given in the data, P1 by P2 is 2/3. So lambda becomes 2 and mu becomes 3. Now we have to determine the speed of point P. Okay. We have to determine the speed of what? Point P. Now again we use the section formula for velocity. So velocity Vp will be written as lambda. Lambda is how much? 2. This is V2. This is V1. They are just magnitudes, but here we write in vector form. So Vp is what? This is lambda. 2V2 plus 3V1 by 2 plus 3. Fine. So this becomes 3V1 plus 2V2 by 5. Alright. Now you see one thing. So Vp is, this is the magnitude of velocity Vp. That is just this much. This becomes mod of 3V1 plus 2V2 upon 5. Okay, this is Vp. Fine. Mod of 3V1 plus 2V2 by 5. Now 3V1 is 30 in rightward and 2V2 is 40 leftward. So 3V1 vector has a magnitude of 30 meter per second in rightward direction. I write it this way, meaning should be clear, magnitude and direction. And 2V2 is 20. 2V2 is 40 meter per second in leftward direction. Multiplication of vector by a positive real number. So resultant, this is the resultant of these two vectors. So angle between these two vectors is 180 degree. So magnitude becomes what? I'll grab this one, fine. So angle between these two vectors is 180 degree. So from the magnitude of vector concept, Vp simply becomes, this is bigger, this is smaller, so 40 minus 30. 30 by 5. That becomes 10 by 5, 2 meter per second. And bigger is this one, so direction is leftward. This is therefore the required answer to part A of the question. Fine. Now part B is this. This is P1, this is P2, again rigid rod. P1 has a velocity of 40 meter per second and rightward direction. P2 has a velocity of 30 meter per second in rightward direction. So this is V1 and this is V2. Now again we have to determine Vp. P is here. Again, as in the part A of the question, Pp1 by Pp2 is equal to lambda by mu, that is 2 by 3. Lambda is 2 and mu is equal to 3. Alright. Now I write this one. So now again using the section formula, vector Vp, velocity vector of point P Vp is lambda V2 plus mu V1 with lambda plus mu 2V2, 2 here vector form, plus 3V1 by 2 plus 3, that is 5. Now 3V1, V1 is what? 40. 3V1 becomes 120 meter per second in rightward direction, and 2V2 becomes 60 meter per second, that also in rightward direction. So these two vectors have the same direction. So magnitude of vector Vp will simply be, since they have the same direction, the magnitudes will simply add up directly. So it becomes 60 plus 120 by 5. So 180 by 5, that is just 36 meter per second in rightward direction. This is therefore the required answer. Alright, fine. So this is the concept of section formula for velocity, which I have demonstrated. So based on this concept, first I have explained the theory, proved the result also, and then I have taken two questions. In first question there is only one part, in second question there are two subparts A and B. So this I have taken these two examples to demonstrate this concept. So if you go through it properly, then it's alright. Fine. So this concept is also very helpful in solving many class of numericals. Okay, so I close this here. Fine. Alright.